Welcome to this spoken tutorial on DWSIM. In this tutorial, we will learn how to do sensitivity analysis and adjust. My name is Kannan Moudgalya. In this tutorial, we will determine the exact reflex ratio for a separation. We will first do this through sensitivity analysis. We will repeat this through the adjust operation. To record this tutorial, I am using DWSIM 3.4. To practice this tutorial, you should know how to open a simulation file in DWSIM, how to carry out rigorous distillation simulation, and how to add components to a flowsheet. Our website spokentutorial.org gives details of the prerequisite tutorials. You can access these tutorials and also all the associated files from this site. This slide shows the problem solved in one of the prerequisite tutorials. This was solved using rigorous distillation. The purity achieved was less than what was desired. How do we improve the purity? We need to increase the reflux ratio. Let us open the corresponding file in DWSIM. The file name is in the heading. I have already opened DWSIM. I have already opened the file rigorous.dwxml. This file is available to you for download from our website spokentutorial.org. Let us click distillate. In the properties section, let us locate molar composition item 2. Let us click the arrow next to mixture. The benzene mole fraction is 0.945. We would like to increase this to 0.95. Let us attempt this by increasing the reflux ratio. This is what we saw in the slide a little while ago. Locate the optimization option from the menu bar to the right of the file button. Let me click it. Let me click the option sensitivity analysis. A window appears. We can see 5 menus in the menu bar of sensitivity analysis. Locate sensitivity studies. If it is not already selected, click it. Now we can see a box with 4 options under the title Case Manager. Click on New option. This will help in creating a new sensitivity analysis case. We see the name SA Case 0. Recall the problem we want to solve. We want to increase the reflux ratio so as to get better purity. Thus, reflux ratio is the independent variable. Let us enforce this through the independent variables button. Let me click on empty space besides the object button. Click on DC 000, the name of our distillation column. On the right hand side, there is an option called property. Let me bring this inside. Let me click the down arrow. Let me scroll down and identify condenser specification value. It comes at the bottom of this menu. It plays the role of reflux ratio. Click and select it. You can see it here selected. Recall that we want our reflux ratio to be greater than 2. So we will enter the lower limit as 2. Change the upper limit to 2.5. Change the number of points to 6. Let us next click on dependent variables. On the left hand side, see a column called variables. Below that, see a plus button in green to add variables. Click it. A new row appears. Click the down arrow below the object. You may have to click it twice. Click on the option named distillate. Let me click the down arrow below property. You may have to click this also twice to open a drop down menu. Locate molar fraction mixture benzene. You will have to scroll down to reach it. There are also other options that sound very similar to it. Make sure that you choose this. Click it. It gets selected and appears on the tab. Then click on Results. We can see the option called Start Sensitivity Analysis. Let me click it. We see the column getting simulated for reflex ratios one by one. At the end of the simulation, we get the message Done. You see results for 6 reflex ratios from 2 to 2.5. We also see the corresponding benzene compositions. We can go back to independent variables. Change the number of points to 11. Return to results. Click Start Sensitivity Analysis once again. You can see that 11 runs get completed. Let us scroll up. See that the desired purity of 0.95 will be achieved between 2.05 and 2.1. You may choose this as the lower and upper limits in independent variables and repeat. But I will not do that now. Continuing in this manner, we can determine the exact reflex ratio required for 0.95 purity. I have an assignment for you. Can you find out the reflex ratio required for 0.95 purity? Follow the procedure I explained just now. I will give you the answer. It is approximately 2.067. We can also see these results in a graphical form. Click on Chart option. Click on Draw option. You can see the chart here, distillate composition versus condenser specification value, that is the reflux ratio. Let me close this pop-up. Let me save the simulation as sensitivity. Let us go to the next assignment. In the previous assignment, include a second dependent variable, benzene mole fraction, in the bottoms. Observe both distillate and bottoms compositions. Find out how to plot two profiles using chart. Let us do another assignment. Verify whether the reflux ratio of 2.067 that we saw in assignment 1 will work. For this, start the rigorous.dw XML once again. Change the reflux ratio to 2.067. Simulate. What distillate composition do you get? We calculated the desired reflux ratio by trial and error. DWSim has a powerful method to directly calculate this. It is called adjust. Let us locate adjust from the object palette on the right hand side. Drag it to flowsheet and drop it outside the column below the distillate. Let me click and choose it. In the Properties tab, we see an option called Controlled Variable. This corresponds to the dependent variable, namely distillate composition. If it is not already opened, click the arrow to the left of the controlled variable and this will open up. Click where it says Click to select. Click the button that comes at the right end. A pop-up appears. It has 3 columns. Below Type, click on Material Stream if it is not already selected. In the Object column, that is in the middle column, choose Distillate. This produces a lot of variables on the rightmost column. Locate molar fraction mixture benzene. It comes after solid phase entries are over. Click it. Once again, be careful as there are many similar sounding options. Click OK. Verify that this gets reflected in the Properties menu. Repeat the above process now, but now with manipulated variable. Click the button on the right. In the pop-up, scroll down and locate distillation column. Click on it. Then click DC 000. Then locate condenser specification value. Click it and then OK. Follow the usual procedure. Now for parameters property. Scroll down to see this. We can see an option called adjust property value. This value is generally 1. Delete 1 and enter 0.95. I shall enter a slightly larger number 0.95001. I want you to think about why I have entered a slightly larger number. A few lines below this, see an option called simultaneous adjust. Following the usual way, change its value to true. If it does not automatically calculate, press play and then recalculate all. In my case, it calculated automatically, so I shall not click those. In a short time, calculations get completed. Let us check whether our objective of 0.95 for distillate purity is achieved. Choose distillate. Check mixture under molar composition. We can see that benzene composition is 0.95. Let us now check what reflux ratio is required for this. For this, click on the distillation column. Check the value under condenser specification. We see a value of 2.067. It is the same as what we obtained in the sensitivity analysis. Let me save the simulation as adjust. I have the next assignment for you. Supposing that I want 0.96 benzene mole fraction in the distillate. What reflux ratio is required? As in the problems we solved, you may change only the reflux ratio. Solve this first by sensitivity analysis. Check your calculations with adjust. Let us do one more assignment. Find the highest distillate purity you can get in this column. You may vary the reflux ratio only as in the earlier assignments. I could go up to a mole fraction of 0.99 by proceeding gradually. Let me summarize. We learned the following in this tutorial: how to do sensitivity analysis, how to narrow the solution range, how to directly achieve the same results using adjust, how to use adjust to push a plant to deliver more. We have come to the end of this tutorial. This video summarizes the spoken tutorial project. If you do not have good bandwidth, you can download and watch it. We conduct workshops using spoken tutorials, give certificates. Please contact us. Do you have questions in this spoken tutorial? Choose the minute and second where you have the question. Explain your question briefly. Someone from the FOSSEE team will answer them. Please visit this site. The FOSSEE team coordinates coding of solved examples of popular books. We give honorarium and certificates for those who do this. For more details, please visit this site. The FOSSEE team helps migrate commercial simulator labs to DWSim. We give honorarium and certificates for those who do this. For more details, please visit this site. Spoken Tutorial and FOSSEE projects are funded by NMEICT, MHRD, Government of India. Thanks for joining.